morning, all y'all. How goes it? Hello to everybody in the classroom. If it's up yet. There's a couple of us here, I think. I don't know. My streaming platform doesn't show me how many people are watching. But that's okay, it's our last stream. It's our last stream for the week. And it should be the last stream for the semester. Because I don't know, I mean, this shouldn't happen again. I hope not. We'll get started in a minute. "18 people ran?" What does that mean? Oh, on right now. Got it. Awesome. Thank you. You know, whatever. I honestly have no idea how many people attended my lectures last year when I streamed everything. All I know is you guys are responsible for the material. You're responsible to listen to the material. I'm responsible for teaching it to you, so it's two-sided. Okay, so let's go ahead and get started. So your midterm is tomorrow. I wanted to go ahead and give you guys some recommendations from me on how to approach Thursday. And then we'll go over as many other topics as we can that we didn't get to on Monday. So here are my listed out recommendations for what to do tomorrow, how to take the midterm, how to approach it. I know sometimes it's not a handwritten exam, and so that's different for you guys. So I wanted to give you guys some tips and tricks, so you have a general idea about a strategy for tomorrow. So first things first, arrive early to your designated room. Like I mentioned on UB Learns, we are in Cook 121 and NSC 205? Hold on, I totally forgot. But it's based on your last name. So there's more room in Cook, so there's more students that are going to be there. I looked at the room itself. It's not the most ideal room to take an exam in, but it's the one we were given. So if your last name starts with A through O, go to Cook 121. If your last name starts with P through Z, go to NSC 205. NSC 205, I think, I honestly have no idea. It's got benches, so it is a little bit more ideal for taking an exam. So just, I don't know, you just gotta work with the room that you're given. So go ahead, go to those rooms, make sure you show up early, 6:45 at the latest. And the reason for that is because there's just a lot of students. And so we just need to coordinate who's sitting where, if anybody needs access to chargers, and it's just easier if everybody arrives early. We're not shuffling at the last minute. Well, I mean, it's not the end of the world if you do come in later, but I'm asking you to arrive early to your designated room. Bring the following items: your laptop and charger, your student ID, and your one-page cheat sheet. So I talked to the other instructors, and we agreed that having a bunch of written work would be a bit obnoxious to shuffle around. So if you do want to bring in something that's written, just condense it to a one-page cheat sheet. And really, this is all you should need. You really shouldn't need access to everything on UB Learns if you take the time to study and just condense it down into a cheat sheet. Because these problems aren't necessarily copy and paste. It's more, what does the syntax look like? So write down, what is the syntax? What are the keywords that you're going to be looking for? Because it's not just, okay, plug in these numbers to a formula. It's, given this problem, how would you write up the code for it? Okay, so one-page cheat sheet. Once you are there, go ahead, sit down, open up the midterm exam folder on UB Learns. It's under midterm. It's wherever you're finding the review material. Sit down, open up that folder on UB Learns. The instructions are already posted there. It's the same instructions that are posted on the review material. Read through those if you want one more time. Go ahead, open up MATLAB, get all of your resources accessible. So if you want to have specific tabs open, or maybe your notes open somewhere else, if you have them on your computer, go ahead, get all of those resources accessible so they're easy to access on your computer and you're not going to be shifting things around a bunch. And then when you do open up MATLAB, you should have a folder somewhere that you're going to store your midterm exam files. Make this your current folder in MATLAB. So my current folder is currently documents MATLAB. That's just because I don't want you guys to see all of my files on Box because there's a ton of them. Make a folder called midterm exam, whatever that looks like. This is the one that I made for the practice exam. But go ahead and make a folder that's going to contain all your files. That way you know exactly where they are accessible, and you don't lose them. Okay, so all of those things to prep for the midterm. The exam is going to start at 7 p.m., which means the link on UB Learns is set to release at 7 p.m. So right at 7, go ahead, refresh the UB Learns page. So refresh the one that says midterm exam. And then you can open up your exam. So you are going to be assigned 6 random problems. They're not in any particular difficulty order. It's not necessarily in any order that corresponds to how the semester unfolded. I think loops is like your 3rd or 4th question. So they're not in any particular order. So what I want you to do is you'll get 6 different random questions. These are questions linked to UB Box. So just like you do your homework, you're gonna click on the link, it'll open up a UB Box file that's gonna be watermarked, you can't download it. So there's 6 different links that you will get. Open up all of the links right away. Just open them right away. Open them in a new tab, so they're all preloaded and available for you to look at throughout the entire time that you're taking the exam. It'll just make it easier to load things and to move on to the next question. Another thing to note is the questions on UB Learns are technically true-false questions because I don't have any other option. So it says on next to each question, like, mark this question as true to indicate that you finished the question. Okay, so the true-false has nothing to do with your final grade. It has everything to do with just the fact that I can't have a blank question that doesn't have some sort of answer required. Okay, but ignore the true-false or follow the instructions. Either one, I don't care. Okay, but what you should do is open up all the links to your UB Box files. So you'll have your 6 randomly generated questions just for you. Okay, so that should take maybe like a minute. So then it's looking at strategy for taking the exam and answering those 6 questions. You have 2 hours. Everything disappears at 9. Which means you have 120 minutes to program 6 questions. There is no lockdown browser that you need to install. We will be walking around, proctoring you guys, looking at your screens to make sure you're not doing something you shouldn't do. Obviously, this is not foolproof. Please let me continue to trust you guys. My default is to trust. Please let me continue that default. So there's no lockdown browser. Mostly because we can't lock down because MATLAB, you need access to the internet in order to access MATLAB because that's where you get the license from. Otherwise we might actually do lockdown, but we can't because MATLAB needs the internet. Okay, so you have 120 minutes to program 6 questions. This means you have no more than 20 minutes to answer each question, which is sufficient. Yes, you're allowed to use UB Learns as a resource, that's fine. So you can open up UB Learns, you can open up all that fun stuff. That's what I recommend you do right here. Get all of your resources accessible. If there is something specific you want to look at on UB Learns, maybe you want all of the homework solutions to be pulled up, pull up the homework solutions before you even start the midterm, before everything's released. So anything on UB Learns you can use, anything on Zybooks you can use, UB Learns, Zybooks, MATLAB. So MATLAB, the help documentation right here, you can type in and it'll open up specifically the MATLAB browser stuff. And then any of your notes that you have on your computer, any of your files that you have on your computer that you can open up in MATLAB, whatever of your specific material you want to use. And your cheat sheet, your one-page cheat sheet of written stuff. Keep in mind, you have to do all of this on one screen, on one laptop screen. I don't know how you guys manage it all the time. I have 2 screens on my desktop, and when I have to go work on my laptop, I'm like crying a little bit inside because there's so little space. So just keep in mind that you're gonna have to manage, your space. Okay, so taking the exam. There are 20 minutes per question, which is fine. They're not large questions. But keep in mind that you get partial credit, so it doesn't matter if your questions work perfectly. So my recommendation is, if you are concerned about time, even if you're not concerned about time, answer each question first. Don't even run the program in MATLAB. Answer each question first, then go back and debug and fix any errors. You've noticed by now that debugging can take forever, especially if you don't know exactly what the problem is. If you're sitting there and you're staring at it and you're like, I keep getting the same error and I don't know what to do, you can get stuck in a vicious cycle of debugging for way too long. That is very true on the midterm as well. So I don't want you to get stuck on any one question and not have time to answer the others. So make sure you answer each question first, or give yourself a hard stop, like you're gonna stop at 15 minutes and move on to the next question. There are no test files. I did not want you guys to have to be sitting there concerned about figuring out exactly what it's going to be like for the test file. Because you do that for the homework already, and I'm sure the homework takes longer than you estimate it's going to take, because you're sitting there trying to be like, okay, I want all the points. So there's no test files. I also didn't want to have to write, all the test files for everything, because I have a limited amount of time. Okay, so make sure you answer each question first and then go back and fix them with the time you have. Okay? That's my recommendation for doing the midterm. There's plenty of partial credit. Make sure you take advantage of that. Another thing to note is you have an unlimited number of submissions. So the exam is going to be released in one link, and then your submission is going to be a normal assignment, just like you do your homeworks. You have an unlimited number of submissions, so you can submit your files at any time, as many times as you want. That's completely fine. Just make sure your last submission has all of your files. I'm not going to sit there and go back and go through all the attempts. So make sure everything is submitted in your last submission, but you can submit as many times as you want. So maybe you want to do that as a fail-safe, halfway through the exam, maybe 2/3 of the way through exam, 3/4 of the way, however you want to do that. Okay, but you have as many submissions as you want. In theory, the instructions say that you have to submit as a zip file. I'm fine if you don't know how to do a zip file. You don't have to submit it as a zip file. If you know how to submit as a zip file, go ahead. I don't care. If you don't know how to submit as a zip file, you're really just gonna right-click on that folder. At least in Windows. I don't know what it's like in a Mac. I apologize to all of you guys with a Mac. It's just not my natural language to speak in terms of what a Mac looks like. I know enough on a Mac to get in trouble. And I could figure it out, but I don't know exactly how. But on a Windows, you would open up your file explorer, you would right-click on that file, and it's essentially send to zip file. Here in MATLAB, it says create zip file. Maybe that's true on a Mac as well. But this is that zip that you would submit to the midterm submission link. But once again, If you submit just like you do the homeworks, I'm totally fine. As long as all of your files are there and I can find them. I am okay with however you submit. Okay, so that is my strategy for taking the exam. And then once you're done, you're gonna pack up your stuff and then go to the front of the room. There's a sign-in sheet or a sign-out sheet. You'll show them your student ID. And show your student ID. Just to indicate that you are physically present, that you are who you say you are. Yeah, there's no issues. So a lot of you guys will be there the entire 2 hours. So keep that in mind. Which means at the end of the time when you're signing out, it might take a while. So just be patient. We will get everybody through the system. Okay, so that is my recommendations for taking the midterm. What to expect on Thursday, tomorrow, what essentially your mental process should be for moving through Thursday, and what you should expect to do on Thursday. Okay. Ooh, I did a little longer than I thought. Anyway, that's fine. Let's go ahead and continue the review material. So on Monday, we talked about loops, we talked about logical indexing, we talked about branching. Beyond that, most students, it was kind of a toss-up between input-output, modifying arrays, and solving systems of equations. So I'm going to focus on those 3 for today, and then if we have time, I'll get into functions and get into the basics, but we've all been relatively comfortable with those, and by far most people did not want those to be the most covered topics on the review. Okay, so here, input output. This is also called managing data in MATLAB. Managing data in MATLAB. It's not my favorite title, so I call it input output because that's what the analogous is to other languages. But we talked about input. We talked about fprintf, we talked about display, save, and load. So some keywords to look out for: prompt, user-defined. Those indicate that there's some sort of input. So that you need to ask the user for a value. If you see the words print out, display with X digits past the decimal point, display text with variable values, that's an indicator that you should use fprintf. If you see printout display with a specific format, such as format short G, if you're displaying just text or just a single variable value, then you should be thinking display. Save and load, they're not in the midterm. Don't worry about those. So these are the ones that I'm going to focus on. Okay? But if you did see save and load, essentially looking at save data to a file, import data, load data from a file, all that fun stuff. Okay, so here's a, once again, not fully formed problem, but it says prompt the user for the last value in a vector. Okay, we see the keyword prompt means we need to use input. Whenever you're using input, our syntax is going to be, I don't know, v equals input, and then our prompt. You're not necessarily going to be given prompts in the midterm, so just literally type something, number. So we're not necessarily going to tell you what to type, so you just have to come up with something. Okay, so I'm going to have somebody input a number. Keep in mind that if you are expecting text, you need this S option. So if you have a number or something numerical, you don't need the S. If you have something that's not numerical or some text, you need the S. Okay, but every single time it's one variable equals input, as we recognized in homework 5, or as we noticed in homework 5. Okay, there we go. I prompted the user for the last value in a vector. Then it says print out the following message. The last value to be used is X. So here it doesn't tell me which one to use. So I'm going to go ahead and show you how to do it with both of them. My preference, if I'm not told which one to use, I would use fprintf for this one because I'm combining text with some data. And we've seen this before in the homework documents where xxx is the value entered in by the user. So if I'm using fprintf, I would say fprintf, then I would literally just type in exactly how I want things to be printed out. The last value to be used is, and you're not going to be graded on spelling either when it comes to text. So if you misspell number, that's not a problem. If you misspell value, not a problem. If you misspell fprintf, that might be a problem, depending on levels of partial credit. There we go, that's the word. Okay, the last value you use is, and then I want to insert some data. And the type of data I want to insert is a number. Type of data I want to insert is a number, so I could do %d for an integer. I'm going to do .0f. It's my favorite way to display an integer. Any specific rating on whether we should suppress every line with a semicolon? So, no, I don't think so. There's no specific rating, unless it's explicitly told, but I don't think there's any problems that tell you you have to. Will there be a correct answer for us to refer to? So, for some of the problems, yes. So for the functions, if you're asked to write a function, it will give you an example, or it will give you essentially values you can use to run your function or to call your function. For a general equation, you're not necessarily going to be given what the correct answer is. You're not necessarily going to be given the correct answer. Sometimes with a function, it will give you an example that shows you what the inputs are and what your output should be, just to help illustrate what the problem is. But you're not necessarily guaranteed to be given a correct answer. So the last value you could use is, and then I'm going to insert some data. So that variable that I'm inserting, or the data that is being inserted, comes from v. So that's what it looks like with fprintf. If you want to do disp, you would essentially concatenate your strings into one set of brackets. So you would create a new array and type the last value to be used is, and then you would do num to string v. That's what that looks like, I believe. Let me go ahead and run my code just to demonstrate. 3. There we go. I have an extra space in there. Once again, you wouldn't be graded. We wouldn't be that nitpicky on the midterm. For the homework, we're nitpicky because you have a chance to correct it, but not for the midterm. Okay, so this is what it is with fprintf. This is what it is with display. Okay, that's one line of text. Then it says create a variable from 0 to the user-defined value with 5 numbers. So anytime you're asked to create a vector, you're thinking linspace or the colon operator. This one, you're given the start value, you're given the end value, and you're given the number of elements. That means linspace. If you're given the start, the end, and the spacing, that means the colon operator. So vector equals linspace 0, my end value is v, and my number value is 5. Okay, then it says calculate the square root of each value in the vector. So vec squared equals vec dot caret squared. I'm using the dot caret because vec is a vector. It's not a scalar value, so I need my element by element notation. Anytime you type a mathematical operation now, you're thinking, is it scalar? Am I working with matrices? Do I want to do matrix math, or do I want to do element by element math? Then it said display the results in a table. So it doesn't tell me what my table is supposed to look like. It will tell you on your midterm what your table is supposed to look like if you're printing things out in a table. So when it comes to printing out a table, you're either going to be told, or you might be told to use disp, you might be told to use fprintf. I'll show you both of them. For display, so printing out display, square root, thank you, sqrt. Basic mistake. For sqrt, it automatically does it element by element. So that's some fun review. Okay, for display, I would literally display my first line. So display, I'm printing out my, this vector and this vector. So my original vector and the square root. I don't know exactly where things are going to be aligned quite yet, but that's fine. Then I can go ahead and display my data. Generally, I want to choose what kind of format. So format short G is a really good one. If you are told to use display, you will be told which format to use. But format short G is like our generic kind. And then I would display my data. When you are displaying, you need to have it in one array. So I'm going to gather all of my data in one array. I'm going to make the first column that I want to print out. So the original data is going to be my first column. That's going to be the first column in my array. So vec transpose. And then the second column is my square root. So I'm going to make that my second column in the array. So vec squared, or square root, transposed. This is what it looks like for display. So here's my, hey, I got that aligned pretty well. Here's my original, or my header line printed out, and here's my data. This is my first column, which is vec. This is my second column, which is vec sq. The problems on the practice midterm are very similar to the ones you'll be seeing on the midterm in terms of number of problems, in terms of complexity of problems. It's very similar. Should we allow ourselves 20 minutes for each question? If you are taking the practice midterm and you're practicing timing, sure, time yourself and make sure you're not doing 20 minutes for each question. But it is a good indicator of what to expect on the midterm, what type of problems, and the complexity. Okay. So that's what it looks like with display. For fprintf, it's very similar. I would do fprintf. I would type out my header, original square root, and then \n. With display, you don't need \n. With fprintf, you do. And then you would print out essentially how you want each column to be printed out. So I want my first column to take up, I don't know, let's say 10 spaces. And then however many digits past the decimal point, we'll do 2. And then an F for a floating point number, which means there's digits past the decimal point. And then my second column, however much space I wanted to take up, let's say 10 spaces as well. And then 4 digits past the decimal point, and then \n. So essentially you're defining what your first column is going to look like, what your second column is going to look like. And then you're going to gather your data into one array where each row in the array is a column that's printed out. Okay, so whatever this was, it's essentially the same but transposed. So here we can see the difference between display and fprintf. And for display, it's just what that variable looks like is plopped on the screen. For fprintf, you just transpose it. So each row in here will be printed out as a column. Yeah, I can post these onto UbiLearns. I'll do that after next lecture. I can do that, not a problem. Okay, so here's what that looks like. And you can see, I mean, you can mess around with it as much as you want to make it line up. You're not going to be graded on how aligned things are because you don't have a specific format that's necessarily told. You will be shown what it should look like, but the TAs are not going to be, the TAs are going to be the ones that are primarily grading, but I'll mention to them at our grading party, because who doesn't like grading, that essentially don't pay attention to the number of spaces per se or the spelling and that fun stuff. Okay, that is input-output, or at least the things I think you should focus on. And like I said, save and load aren't really on the midterm, but don't tell anybody I said that. Okay, that is input-output. Let's go to arrays. So arrays, there's some supplemental videos that go over this material that I created back in like week 4, that go over homework 3 that you might find useful. But here is another example of talking about arrays. So when we're talking about array manipulations, some keywords indicate modifying array. You're talking about changing columns, you're talking about changing rows, you're talking about appending. And we talked about different ways that we can create arrays and then modify them. Once again, this comes down to what I talked about in logical indexing in terms of what do we want to change goes on our left-hand side, and what do we want to put there goes on our right-hand side. So here it says write a function, so I'm going to review functions here at the same time. Write a function that takes in 3 inputs, an array of arbitrary size, a number corresponding to a row, and another number corresponding to a row. So function is what we type when we are creating function. I'm going to have my outputs equal the name of my function. You will be told explicitly the name of your function. You will be told explicitly the number of outputs, what they're called, explicitly what the number of inputs, what they're called, just like you are in your homeworks. Keep in mind, you can name your variables whatever you want, as long as your function name is appropriate. So function name, woohoo. Okay, and I have 3 inputs, an array, row 1 and row 2. And then it returns, so here's another indicator, or no, returns, I'm thinking of something else. And returns, so that's my output, the input array where the row 1 is divided by the values in the second row. So it's just another array, A out. I can call it A in and A out. And then every function has an end. Ooh, a lot of you guys don't write the end, and it's not necessary. You're not given an error for it in MATLAB when you write functions, but it's just good practice to have an end. So anytime you write the word function, write the word end. Same thing with if statements, same thing with switch statements, same thing with for loops, same thing with while loops. Always put in that end. Otherwise, MATLAB's gonna be like, can't compute, don't know what you're talking about. Okay, so when you're writing a function, make sure you write your H1 lines and help text line. Your H1 line is your summary, function name, and then you describe, short description of the function. And then you do your use case, which essentially is how you call the function. How you call the function is literally just this. It's exactly how you call it. And then your inputs and your outputs. You're going to be writing a couple functions on the midterm. I think it's 3 functions. I can't remember exactly. It's 3 or 4. You will have to write help text lines and H1 line for some of them, not all of them. So if it explicitly tells you that you have to write the H1 and help text lines, write them. Easy points. If it does not tell you, if it says you don't have to write those, then don't. Ignore them. You don't need those points. Okay. So, takes an array of arbitrary size. So A is any size array. It can be a 2x2, a 3x3, a 7x7, a 9x9, a 2x5, a 7x3, any size array. And it takes in 2 row numbers. So these are rows that correspond to this array. So it's going to return the input array where the row, this first row, is divided by the values in this row. So first things first, A out needs a value. I'm going to go ahead and start by saying A out equals A in. So I'm saying at minimum, my output array is the same as my input array. I'm going to start there. Then what I need to do is figure out what do I want to change and what do I want to put there. So I want to go ahead and change this row, whatever this value is. So if it's, I don't know, let's say A in is a, and you'll have examples. So you'll have examples. Rand I, let's say it's a 3x4. You'll have an example. Let's say R1 is 1, or 2, I guess, and R2 is equal to 1. So essentially it's saying the input array, so it's the same, A out is the same as A in, where the row in row 1 is divided by the values in row 2. So I'm going to take this row and divide it by this row. Use your example to help clarify what you're trying to do. Okay, but this one essentially would say that if I used A in R1 of 2 and R2 of 1, I would change this row by dividing it by the corresponding values in this one. So essentially I'm saying that A out, my second row, or all the values, no, in row 1, all the values, that's how I change a single row. JZ, you're not graded on your comments for your script files. I don't think there's any instance where we say you need comments for the script files, but you can use them to help annotate your code and help give the TAs and the graders context for what you're trying to do if you can't figure something out. But you're not going to be graded on comments for the script files explicitly unless you want to put in some comments to help give context to what you're trying to do. Okay, so here, I'm trying to change this row. I'm trying to change row 1, so row 2, here, all the columns. If you want to, start with actual numbers. So I'm trying to change row 2 by saying it's equal to the values in row 2 divided by the values in row 1. Keep in mind, anytime you use a mathematical operator, you're checking, am I dealing with scalars or vectors? And if you want to do matrix math versus element by element math, I want to do element by element. But as you said, comments will give you an upper hand for partial credit if you're stuck on something. They can help give context for us. Because otherwise, if you make a mistake and you know there's a mistake and you can't figure it out, all we know is that you just typed something. Whereas comments would help give us context to indicate that you have a general idea that this is what you're trying to do. It's not quite working. Okay, so I went ahead and I used these physical numbers, but then you have to replace your numbers with your actual variables. So I used R1 is equal to 2. So this would be R1. This would be R1. And then R2 was 1. So there we go. So I'm saying replace whatever row R1 stores by taking the values in row 1 or in R1 and dividing them by the values in R2. Whatever rows those are. If you ever want to test your file, your function, you need to save it with the correct name. So I'm gonna rename this and say arrays because that's the same as my file. Okay, so now you can say arrays. So how many outputs? A equals arrays, A in R1, R2. So here we go. I can see that row 2 was changed. It took 6 divided by 3 to give me the 2. 2 divided by 10 to give me the 0.2. 5 divided by 10 to give me the 0.5. And 5 divided by 2 to give me the 2.5. So you can always check your functions by calling them in your command window with whatever values. Like I said, with the functions, you will be given values you can test your function with. So just use those if you can't think of anything. Another thing to keep in mind is this function's really short, so we can add in some error checking here. We can check to see if R1 and R2 are actually valid rows in in. So if, what's the size? The number of rows in A is size of A in, comma 1. So I can check to see if R1 is less than or equal to the number of rows, and R2 is less than or equal to the number of rows. That's when I want to do this. Otherwise, I want to end. So here I have some error checking, which expands my function, makes it a little bit longer, but I can check to see if this will actually work. I can also check to see if they're greater than 0. So, and R1 is greater than 0, and R2 is greater than 0. So if you're told to check to see if your inputs are valid, this might be something you have to do. Once again, with if statements, it's kind of hard to pick out keywords, but if you're checking to see if something is valid, or if you have to do some error checking, you're really thinking about if statements, your branching statements, you're deciding whether or not you should do something or not do something. So if you have valid inputs, then do the function, otherwise don't. So now, if I did A equals arrays, A in, with like 10 and 10, it would give me my original A back in this instance. We could add in and say A out equals -1. So that would also change our function and give me different outputs depending on whether or not I have valid inputs. So that is arrays, an array manipulation. Key thing, what do we want to change? What do we want to put there? Use your example as a starting point. If all you do is set up the example, that will help. And if all you do is write the code that sets up the example, that's fine. Keep in mind, you should never say in your function that AN equals something, or R1 equals something, or R2 equals something. That is not valid. If you ever see this at the top of your function file, then comment it out, ignore it, delete it, whatever you want. It should not be code in your function. It might help if you leave it as comments. It might help you identify what your inputs might look like, but it should not be code in your function. Okay, that is arrays. Let's go ahead and talk about solving systems of equations. Yes, I did see it. Okay, so just like in your practice exam, there is a question on solving system of equations. In your practice exam, I think it's a large one. It's like a 7x7 or something like that. Here's a relatively small one. But this really is assessing your matrix math. Most of the time, you want to do element by element math. Most of the time. That's what you want to do. Here, we wanted to do element by element math. Here, I wanted to do element by element math. Nope, didn't do anything there. I don't know. Here, I wanted to do element by element math. I don't think there were any loops. Most of the time, you want to do element by element math. Sometimes, though, you want to do matrix math. And usually, at least at this point in time, the keywords to doing matrix math would be solve the system of equations. So here is a system of equations. When we solve a system of equations with MATLAB, we are going to type in our values for A, type in values for B, whatever you call your variables, it doesn't matter, and then solve for X, which means literally X equals A left divided B. This is the same every time, and then that's it. We've solved our system of equations. So for this system, my typing in values for A, this is my coefficient matrix. For B, this is my constants matrix from your right-hand side. We literally just type in those values. So A equals, for A, we have, if we look at the system, we're going to count the number of unknowns and the number of equations. We have 3 equations. That's easy to see. Our unknowns are X, Y, and Z. I was lazy. I named the next X, Y, and Z. In your homework documents, usually you see X1, X2, X3, I1, I2, I3, whatever you call them. Okay, but these are your coefficients, or these are your unknowns. So X, Y, Z. Essentially, we are creating some sort of grid that indicates that we're going to have our X values in this first column, our Y values in the second column, and our Z values in the third column. And then it's going to be for equation 1, and then for equation 2, and then for equation 3. And we'd be done. So we just fill in this grid. So for equation 1, X has a 1 in front of it, Y has a 2 in front of it, and Z has a 0 in front of it because it doesn't exist. That's for equation 1, then my semicolon. For equation 2, X has a 0 in front of it, Y has a 1 in front of it, and Z has a -1. And then a semicolon. For equation 3, X has a -2, Y has a -1, Z has a -3. There's A. B, doesn't matter what you call your variables. B, the constants from the other side. So it's 11, -1, and 19. Keep in mind, B is a column vector. So you either enter it in with semicolons between the numbers, or you create a row and then transpose it. So here's A and here's B. To solve for X, we just type in that line that I mentioned. X equals A left divided B. Make sure your variables are named the same. Woohoo! Okay, so matrix is close to singular or badly scaled. That means that my determinant of A is 0, or close to 0, which means I typed in something. That's fine. Okay, regardless of what values you get, that's what it looks like. I'm going to change this to a 1. It'll give us better answers. There we go. There's better answers. I must have typed in something wrong. I think I copied this over from something. I probably just mistyped. Okay, so there's my A values, there's my B values, there's my X values. Voila, I did it, I'm done. If you want to display them nicely, you might be asked to display them nicely. There will be more to a problem like this, obviously, just like there is on the practice exam, so use that as a reference. But when you're solving system equations, we're talking about matrix math, so keywords, solving system, use matrix math. Type in your values for A, type in your values for B, X equals A left divide B. That's it. You're not typing X equals XYZ. You're literally just typing X equals A left divide B. You can't type in X, Y, and Z because you don't know what they are. Your whole point is to solve them. Okay, but you're not going to have in your problem, in your code, anywhere that says X equals, Y equals, Z equals. You just know that when you solve your system, that when you create X, or whatever you call your variable, you call it answers, you just know that when you have your answers vector, this is your value for X, this is your value for Y, and this is your value for Z. Okay, there's that one. That's functions. I already went over functions. Let's just go over some basics, just to review. So, back in week 1, really, we learned how to write an equation. So this is our last problem. So here it says calculate the following equation for X values between 0 and 100 and Y values between negative 100 and 0. It doesn't give me a spacing, it doesn't give me how many values, but for this problem I'll show you guys what it looks like with the colon operator. So my X looks like my starting value for X is 0. My ending value for X is 100. In between those numbers is where you get your spacing. So whatever you want your spacing to be, I'm going to say my spacing is 5. It'll give me lots of numbers. For Y, my starting value is negative 100. My ending value is 0. In between there goes my spacing, and your spacing can be positive, negative. It doesn't really matter. I'm going to do a positive spacing of 5 again. Here's my X and Y. I can look at my workspace, and I can see that they're both 21 values. 21 X values, 21 Y values, which is important. That's important, because when I do my calculation, so now I'm going to go ahead and do my calculation. So Z equals 0.6 times X values raised to the 3 times E raised to a number. So I typed it like this on purpose. This is invalid MATLAB syntax. Whenever you're using E raised to a power, you need to use the EXP function. So negative 0.47 times Y plus 1.5 times Y squared times, once again, I need to use the EXP function. EXP, negative 0.6 times X. Make sure you put your asterisks in every single time that you're doing multiplication. I can't just say 0.6x, that will give me an invalid. You need an asterisk every single time. Other things to think about is if you're using a trig function like sine, cosine, tangent, keep in mind there's 2 different versions, one for degrees and one for radians. I was gonna say non-degrees, but the other option is radians. So make sure you're using the appropriate one for that. If you have to take a log of something, keep in mind log is the natural log and log 10 is log base 10. Okay, so keep all that fun stuff in mind. Okay, so I've typed my equation, but once again, anytime you're typing equations, be thinking, am I using scalars? Am I using vectors? Do I want to do element by element, or do I want to do matrix math? Here, X and Y are vectors, so I want to do element by element math. So I'm going to go ahead and put a period in front of every asterisk, every caret, and every division sign. Some of them are not required. This one is not required because it's just a scalar. This one's not required, this one's not required, and this one's not required. But you're not penalized for having too many. Okay, so I would rather you err on the side of doing it in front of all of them and not missing one versus missing one and not getting it. Okay, I'm gonna go ahead and display my answers just so that we can see them nicely lined up. So X transpose next to Y transpose next to Z transpose. Play. X values, Y values, Z values. And here we go. Ooh, that is not lined up at all. That's okay. So here I can see here my x values go from 0 to 100. Y values, or x values go from 0 to 100. Y values go from negative 100 to 0. And my z values end up being between 1,500 and something much, much larger. So 6 times 10 to the 5, 600,000, 6 million, one of those numbers. I can highlight it. There we go. 600,000. There we go. That is our basic calculations. Okay, so I think I went over pretty much all the topics that we talked about over this semester thus far. Make sure you follow my recommendations and modify them to match you. As you go to the midterm on Thursday, tomorrow, I will be there. I will see you guys with my mask on. I'll stay away from people, but it's been a week, so I should be fine. And yeah, after the midterm, make sure you guys go watch the plotting videos, and work on your homework 8, and I will see you guys tomorrow. It'll be great. I'll stick around for some questions if you have any. So that's a good question. What else should you do? Create your cheat sheet. Create your one-page cheat sheet. This is a common technique used by instructors to essentially aid students in terms of their studying. Creating that cheat sheet is probably one of the best things you can do for your studying, because it helps you gather all the information that you think you need. It helps you review for things. So that's what I recommend you would do. Take the practice midterm. If you want to, go look through all of the homework problems and look for the keywords that I talked about. So for loops, those keywords, for branching, for those keywords, all that those fun keywords, to kind of get yourself familiar with more problems, and what you should be looking for. But other than that, I mean, if you've been doing your homework, if you've been doing your due diligence, you should be fine. The sheet can be typed. I don't care. Type your sheet. Yeah, that's totally fine. Anything else? It's gonna be great. Good luck, y'all. See you tomorrow.